All right, good morning. This is for Elements of Calculus 2. Let's go ahead and have a look at what we are trying to do today. We have problem number 6. So we have solved the differential equation. X dy by dx minus 5y is equal to x squared with the initial condition y of 2 is equal to 12. So I've just gone through and wrote down the problem here. And let's go ahead and take a walk through it. The first thing you want to do is you want to clean off the dy by dx. This has to be by itself to be in proper form. So the first thing we're going to do is we're going to say dy by dx minus 5y over x is equal to, we divided everybody by x, this is just equal to x now. Okay, we just divided everything by x. Now, once we've got a clean dy by dx, the next thing we do is we say, okay, find the integration rate. Construct the integration factor. So we're going to go ahead and construct integrating factor. Okay, and that is usually is rho for integrating factor. This is e to whatever is in front of the y here, including the sign. So e to the negative 5 over x dx integrate. Okay, that's how we generate integrating factors. So we have to go ahead and integrate this thing. It's not so bad. It's e to the negative 5 integrating 1 over x is ln of x, and the dx just goes away. The plus c will, technically, we could multiply through. Plus c would be e to the c on both sides. It'll multiply through on everything because that's what we're dealing with. It'll drop out later. So don't worry about the plus c. I'm not going to have to worry about that. Now, I don't like having to deal with e to the negative 5 natural log of x. So what I'm going to do is I'm going to use a logarithm property which says e to the ln of x to the negative 5. Okay. Be very careful about this because even my actual proper differential equations class, when I put this problem on their first exam, they almost always try to do this too fast and get the problem wrong. So this is a problem that traps a lot of people. Don't fall for it. Okay, but this is e to the natural log of x to the negative 5. This is just x to the negative 5. Okay, that's a property of logarithms and exponents. They undo each other. That's the whole point. So what we're going to do is we're going to multiply both sides by x to the negative 5 here. Okay, so we'll go ahead and we'll say x to the negative 5. And then we're just going to go up here and say, okay, that's times dy by dx. Okay, minus 5y over x times x to the negative 5. Okay, equals x times x to the negative 5. Let's clean this up a little bit, shall we? This is x to the negative 5 dy by dx. Okay, we have minus 5. We have an x to the negative 5 times 1 over x. That's x to the negative 6, okay, times y. Okay, leave the y alone. Equals, on the other side, we're going to have x to the 1 minus x to the negative 5. That's going to be x to the, I believe, negative 4 there. Okay, now I like to double check to make sure, is this actually a derivative? We're going to say that this is the derivative of x to the negative 5 times y. Okay, and if I wanted to take the product rule here, right, it would be derivative of the first, that would be negative 5 x to the negative 6 times y, plus the first x to the negative 5 times the derivative of the second, just to make sure. Do I have a dy by dx sitting here? Hold on, go and check. We have a dy by dx times x to the negative 5 minus x to the negative 6 times y. We sure do. This thing here, this piece that we just generated, is the derivative of some product rule is equal to x to the negative 4. Okay, so now that we've verified it, we don't really need this anymore. I'm going to go ahead and take the integral of both sides. Fundamental theorem of calculus says if we take the integral of a derivative, we just get back that original thing, technically plus a constant. Plus, and then we're going to have x to the negative 3 divided by negative 3 plus c. Okay, and then what we're going to do is, I just want this in terms of y. So I'm going to go ahead and multiply by x to the 5th on both sides to sort of cancel out this x to the negative 5 on the other side. So we end up with a y equals, this is 1/3. Rules of exponents. 5 minus 3 is x squared plus c x to the 5th. Okay, now comes the hard part. We have y of 2 is equal to 12. That means when x is 2, okay, y is equal to 12. Let's see what c is going to be because of this. So we're going to say 12 is over here, equals to 1/3. 2 squared is going to be 4, plus c, and then 2 to the 5th, that happens to be 32. Okay, it's just one of those weird things that I picked up a long time ago. And we've got something like that. So we've got 12 is equal to 4/3 plus 32c. And we're trying to solve for c here. Okay, let me see here. What do we want to do with this? Does any of these have minuses? I'm just trying to double check to make sure I'm in the right spot here. All right. Um, all right. So the next thing I'm going to do is we actually have to go ahead and multiply, or we have to go ahead and solve some things. So let's see. Let's see, what do I have? Yes, equals that. So let's go ahead and get rid of the 12. So we're going to say, okay, we need to solve for c. Okay, so we're going to say this is 12 minus 4/3, okay, is equal to 32c. Just algebra. Sorry, I lost where I was going with all of this. So we have that. And then we're going to say, okay, I need to get common denominators here. So we're going to multiply by 1, 3 over 3. 12 times 3 is 36 over 3. That's 12 minus 4 over 3 is equal to 32c. Well, 36 minus 4 is 32 over 3 is equal to 32c. And to go ahead and divide both sides by 32, right? That'll cancel out. So c is equal to 1/3. So let's go ahead and write down our final solution here, our final answer. So we have y is equal to, okay, let's go back up here. We have 1/3 x squared, 1/3 x squared, and then c was to plus 1/3, and then this is going to be x to the 5th here. Okay, back from what we had all the way back up here where we had our answer. I'm going to do one more thing. I'm just going to multiply by 3 because I didn't like the fraction. So I'm going to say 3y is equal to x squared plus x to the 5th. And I'm going to say there's my nice, neat, and presentable solution. Okay, you didn't have to do that. You could have left it like this. It's fine. Okay, so I hope everybody is studying well for the exam. I hope everybody is well for the exam. And I hope everybody's studying is going well. So thank you for watching the video. And good luck when you go ahead and take the test. All right, thank you.